Welcome back. Now we'll move on to the problem number 41 in probability. This problem says two dice are rolled if it is known that at least one of the dice always shows 4. Find the probability that the numbers appeared on the dice have sum of 8. So as it is a problem of dice, we will make that matrix. We always used to solve it by this matrix because it is easier to count the variant according to the requirement. Okay, so in one shot I can put it one matrix where all kind of variants can be represented as the sum of the numbers, as the combination of the numbers, or any other things that is needed to be counted in one go. You can count. So it is very easier and is a very useful tools if you like to use it, or otherwise for every case you have to find all the variants accordingly. So if you use it, then you can find the easiness of this tools. So I always prefer of these tools whenever you try to solve any problem regarding the dice. Okay, so now in this problem it says there are two characters, two events are coming. One is getting 4 in any of the dice and the sum of the numbers is 8. Okay, there could be possible that one of the participant is 4. So where the 4 is coming, the combinations of the 4, for if I say this is dice 1 and this is your dice 2, so either you will get 4 here. So with the 4 the combination will be 1 4 2 4 3 4 4 4 5 4 6 4. This way, when 4 is a element of dice 1 and that is appearing every time with a combination of dice 2, or else this dice 2 have the 4 element is appearing with combination of the dice 1, in a sense that this will be the cases what I am writing here. So that means 4 I am fixing here in the dice 2 and 1 2 3 4 5 6, that is the possible outcome of dice 1 to be appeared with the combination. So these are the cases where how many cases? 1 2 3 4 5 6 7 8 9, this is common, 10 11. So getting the event, if I say getting 4 is an event, the probability of getting E is how many times, or the you can say the count of event E. I will make it count of event E is 11 times. Okay, now I will come to the point where it is needed to consider when 4 is always coming as an element when you need to have 8 as a sum. So now the second is getting sum of 8. So sum of 8, if I see the combination 6 and 2, here 2 and 6, when 3 and 5, 3 and 5 will be here, 3 and 5, 4 and 4, 5 and 3, and that is 6 and 2. So these are the cases where we get the sum of 8. I am marking this with a circle, you can understand. 6 and 2 together 8, 5 and 3 together 8, 4 and 4 together 8, 3 and 5, 2 and 4. So my probability of so you can name it the event F where sum is 8. So this is how many cases? 5 cases. So this is the number of F as is number if is 11, number F is 5. Okay, so then my case where to consider when one of the element is already 4, that could possible that dice 1 having 4 and I want to get some combination to get 8, and or dice 2 having a 4, like that. So my probability of getting 8 means F when E has already appeared will be marked as probability of getting F intercept E and probability of E itself. Okay, so probability of getting 4 with the combination of other is 11 cases. So probability the intercept where intercept will come where only 8 as a sum I will get. So F intercept E I will get 1 4, but sum was 8. So in all these cases only one thing where these things are common, that means getting 4 and sum 8. So that is the only case, means number of this is 1. That means in such cases 4 are appearing, in such cases 8 as a sum is appearing, but all are not common. Here also 4 getting, but sum is not 8. If I consider all these 3, all these 2, there 8 is not appearing. In such cases they are also not appearing. In all these cases 8 is appearing, but 4 is not there. Only one case where this is appearing. So the intercept F8 means with E appearing is only one. So this, if I say F intercept E and number of E, event E. So number of event E is getting 4. So getting 4 number is 11, and F intercept this is 1. So this by 11 will be the probability of getting. By practically also you can see it that in one cases out of total 11 cases you are getting that result where 8 as a sum I will get if 4 is a member of contributor of one of the contributor. Okay, so this is your result. Okay, next coming to the problem number 42. Okay, so 42 says 2 coins are tossed 500 times and we get 2 head 105 times, 1 head 275 times, and no head means 0 head I am writing. 0 head or no head is 120 times. Find the probability of each event to occur. Okay, so I have to find where 2 head is occurring, the probability of that, 1 head is occurring, probability of that. So what is the case when two coin are tossed together for 500 times? So there may one confusion may arise in this case when two coin are tossed. So if it is 500 times, so there must be 500 into 2 number of experiment. So sample space must be of 1000 events, no, 1000 experiments. But if I see this, the result getting 2 head is 105 times. Why I am saying this deliberately? This is this much of this problem have only this having the criticality to understand. And when you are counting 2 head for 105 times, it is a odd number you can see. But if I consider any number of, if the both the cases are head or both the cases are tail, your number of event must be even, isn't it? Because you are tossing 500 times and getting 2 head, it cannot be a odd number, must be an even number, because tossing one coin is getting head and other coin getting head, so all together it is an event of 2. So any number of such cases, if you multiply it with any number, whether it is even or odd, multiplying a 2 will always get even number, but here it is marked at 105. From this you need to understand the event, the tossing of 2 coin is considered to as one event. So it is not a two several different event being considered. So whatever we calculate, whatever number it is showing, it is the result of tossing 2 coin considering is as one event. So that means one head you are getting. So in that case, getting one tail also will be equally treated. One head getting, that means other you are getting one tail with combination of head. So the times is also 275 for getting one tail and no head at also to be. So if we add this all 105, 275 and 120, what are the things coming? 0, 5. You can see the all together it is giving 500 times. So the total number of experiment or the sample space is 500, not 1000. So this conclusion has to be drawn first, then it is very easy. Now if I consider 3 events with the 3 name, E1 be the experiment 1 where 2 head is achieved, is 2 head. Event 2 hit 275 numbers. I can consider this number, that is number also, and this is 1 head you are getting, and number of E3 where you are getting 120 numbers or 0 head. Okay. So now find the probability of each events. So basically getting probability of event 1, it is total the favorable occurrence, because this probability can be measured with the number also, number of events. So 105 of events divided by the total number of sample space, means sample space size. So this is the case. So 521, 500, this is, so 0.21 is the case. Probability of E2 is 275 by 500, so that means 500, so that means 0.55, and probability of getting event 3 is 120 by 500, so that means 525400, that means 0.24. So if you add this all, you will get 1 definitely. So probability, and as because these are not intercepting, there is no common space in between, common space. So these events in a sample space are disjoint events. So for disjoint events, the probability of the intercept of event E1, intercept E2 and E3, this is equal to 0. So the probability of the union or the sum of this will be in a sample space individually can be added to get the whole probability. Understand? So this is one of the property also where your intercept is 0. So in that case the union is being added and you will get the result. Otherwise, if intercepts are there, your probability of the results will be differ. We already shown you by taking 2 events. This time this is 3 event. So this could be similarly will be extended. This is E1 intercept. This will come as the first part is same, but the final result will be affected by their interception of taking 2 together. Okay, intercept of E2. So this part you have to deduct because this is the common space is coming when you will add this, if it is having interception. So this part has to be deducted from the total sum. understand, and it will go on this way if number of events increases. So earlier we shown with the two events, where two events come, so add this two and you deduct one intercept in between. So as there is three events, so accordingly you have to extend the formula and you have to deduct taking two together in a combination, and you have to deduct the interceptions in between. Okay, so this is one of the property, and where interception is not there, it is a distinct events, disjoint events or distinct events, so their interceptions is become zero. So in that case this formula will be reduced to this way. So this also can be used as a direct formula where this is applicable. Understood? Okay. Coming to the next problem number 42. A tire manufacturing company kept a record of the distance covered before a tire needed to be rejected. The table shows the result of 1000 cases. This is being marked as distance against frequency of replacement of the tire. So the distance covered less than 4000, the frequency of changing is 20. This is said like that, no? So the manufacturing company record a distance covered before the tire is needed to be rejected. So this is 20 frequencies where according to the distance tire being failed. So they want to analyze the performance of that tire. So the distance 4000 to 9000 is 210 times. So they have taken a sample space of 1000 cases. Okay, and the distance is, it is 9001 to 14000, 325, and it is more than 14000, the cases are 445. Okay, if the tire is bought from this company, what is the probability that one, if has to substitute before 4000 kilometer in is kilometer is covered? So the first case where seeing this result, you have to get the probability that the substitution before 4000 kilometer, where 4000 not even run by 4000 kilometer, the substitution has happened, has and need to be changed. So probability of the event, the sample space 1000, and your total count, if you count it, is distributed in 1000. So the sample space, when the probability of getting less than 4000 and replacement, it is the count of that frequency upon the 1000, the total sample space. So this is how much? It is 1 by 50. So this is the count for this first answer. Second is last more than 4000 kilometer. So that this is first one. Second was last more than 4000 kilometers. So what are the cases which is more than 4000 as a whole? Starting from here, every kilometer is more than 4000. Crossing 4000 and going further, is all cases are more than 4000. So the second plus the last more than 4000, that means more than 4000 will be the case of probability where you have to add all this, leaving this aside. This is less than 4000. These all cases are more than 4000. The 210, 325 and 440, and so deduct only 20 from the 1000. So that is 980 will be the case, and this is 1000 will be the case. So your probability will become 0.98. Here your probability will become 0.02, isn't it? Here it is 98. And the third case, if has to rejected after 4000 kilometer and 14,000 4,000 and 14,000, means in between they have to reject it, between crossing more than 4,000, but before 14,000 have to reject. So this case will only be will be discarded, and this case also to be the extreme cases has to be discarded for this case where 4,000 and below 14,000 has to be considered. So this together is how much? If I see the third case where this is in between 4,000 and 14,000 is the frequency. So this your 210 plus 325 together is 535. So 535 upon 1000 is the case. So this is 0.535. Okay, is the probability where you need to change the tire. Understand? So I will end up here. In the next video I will start from problem number 43 and onwards. Thank you for now.